Okay, so adding and subtracting radicals. And again, for keeping up notes, this is number 21. It's May 5th. So Cinco de Mayo, if you're a Cinco de Mayo kind of person, or if you're a Star Wars person, it's Revenge of the 5th. So, whichever one you want there. Okay, big thing is just, again, flashing back to the things we've been working on the last couple of days. Remember when we were talking about these? The index is the number that's in the top corner of your radical that's here, and whatever's on the inside is the radicand. So just kind of keep that in mind when we go through these. With adding and subtracting, there's really the first two things that we have to look at are really more of checks than that you don't do anything. So the first thing is you have to check for is that the indexes are the same. You cannot add a square root and a third root together and come up with an answer. So, if we're doing fourth root of this and fourth root, the index has to be the same for whatever things you're going to add and subtract. The second thing you have to have, and these two are kind of interchangeable. You can go back and forth. The order is not really specific because you got to have both of these before you get there. The radicands must be the same. Okay, so once you've checked off that the index is the same, once you've checked off the radicand is the same, finally the third thing, and this is where you get to do the adding and subtracting, you add or subtract the coefficients. Whatever the signs tell you to do in that case. And if you remember yesterday, we said coefficients, that's the number that's going to be in front of your radical symbol. All right, and then one thing you've got to try to remember to do for this one is that you do not change the radicand. And we'll show you, kind of how that goes for this thing. Okay, so adding, subtracting for the most part is really basic. As long as the index is the same, as long as the radicand is the same, you take whatever numbers you have on the front out here, your coefficients, and you add them or subtract them, whatever the signs would say. Okay, so let's say you have 7 on the third root of 5 plus 5 on the third root of 5. Good. Indexes are both 3. Radicands are both 5. So 7 plus 5 is 12. And again, after you add those numbers, you do not change the radicand. It stays the third root of 5. And hopefully you go, well, that's not really hard at all. No, it's not. Adding, subtracting, as long as the radicands are the same and the index are the same, it's really easy. You take whatever numbers are on the outside and you add them. And you can almost think about like this being an X, big giant X through this. It's like 7X plus 5X. Not that you have to do that. But as long as these are the same, if that's, then you can think about those being like X's, well, then that's just 7 plus 5. So it's like 7X plus 5X. You can almost think about it like that. That if one of these is different, this is like if this was the third root of 5 and this one was the third root of 6, well, that would be like an X and that would be a Y. So you couldn't add those two things together. So that's the big thing you have to kind of realize is that if you're going through these, as long as everything is the same, you just add or subtract the numbers that's in front. It doesn't really matter how the numbers look in front. We may have like 3x on the square root of xy minus 15 x square root of xy. Let's make it 18. So 3x times the square root of xy minus 18 times the square root of xy. Okay, they're both square roots, so the indexes are good. The radicands are both xy, so now we're just doing 3x minus 15, or 3x minus 18x That would be negative 15x. And then you just tack on the square root of the xy that's there. Let's go treat you. Okay, and that's it. That's all you got to do. So as long as the coefficients or the radicands are the same, just add and subtract the numbers in front. Again, some of them have some variables, but most of the time you're looking at just plain numbers that's here. All right, so here's what you have to do if the radicands aren't the same. It'd be nice if you could just go, oh, they're not the same. Okay, we're done. We don't need to worry about the problem. But here's what you have to do. If the radicands are different, simplify the radicands if it's possible, because they might be sneaky and give you some that don't simplify. I doubt it, but they might be, they might could get sneaky on some of these problems and give you a problem that if you break it down, then there's still nothing that really works for this thing. So if the radicands are different, simplify the radicands if it's possible, which most cases it should be, and then add or subtract if possible. All right, and we'll give you a short problem, then we'll build up to some bigger problems. So let's say you have square root of 12 plus square root of 3. All right, now, and I guarantee you on the test, there will be, if the multiple choice questions, if you have one of those, this one might possibly be a fill in the blank one. But if there's multiple choice, one of the options on the multiple choice is going to be the square root of 15. Because we're always looking to see, oh, if you just do 3 plus 12, that's 15. But that would definitely be wrong because, again, the radicands have to be the same to be able to add these things up. So what you've got to do then is you've got to take the 12 and then start to break it down. Maybe 4 times 3. All right, and hopefully when you start to break that one down, if you have 4 times 3, you go, oh, well, square root of 4, that's just a perfect number. That's a 2. So I can make that 2 square root of 3 because this one was already square root of 3. And if you haven't gotten a habit of doing this one yet, yesterday when we were doing multiplication, we were saying to put a 1 for an exponent. When you're adding and subtracting these, always go back and put a 1 in front of every square root if there's not one. Just like if you were going to do x's, if it was 2x plus x, you have to realize that there would be a 1 in front of that x. So you could do 2x plus 1x to get 3x. Well, with radicals, it's the same thing. If it's 2 square root of 3 plus square root of 3, you've got to realize that there's a 1 square root of 3 here. So when you do this, it's 2 plus 1, so that would be 3 square root of 3 for the final answer. Okay. And a lot of times it's the little things. Somebody will break this one down, they'll be good, and they'll go, oh, it's 2 square root of 3 plus square root of 3, and they'll just tell me that it's 2 square root of 3. I'm like, oh, well, you've got to remember that anytime there's a square root without a number in front, without a coefficient, you've got to put a 1 there that's understood so that you can start adding those two things together. Okay, now, and we think a lot with square roots because it's numbers that we've kind of worked on. You'll get an occasional 1 or 2 that's going to be something other than square root. So let's look at one of those. Let's say we're doing third root of 250 minus the third root of 16. And we'll come back and do some more square roots because square roots, I think most everybody does pretty good with them. Third roots and fourth roots and fifth roots get to be a little bit more difficult because we don't do a lot with those. So we'd still need to throw some in there to practice just to be on the safe side. Because most people, square roots, we do enough of them. We do 2 times 2, and we do 4 times 4, and we do 5 times 5. That if we were running across these, if we did square root of 49, we know that would be 7. Most people, and that's me included, don't know what these perfect cubic numbers are. that I don't, 6 times 6 times 6 is not right on the top of my head. If I sit there and think about it, sure, I can figure it out. But, I don't know what 7 times 7 times 7 is right off the top of my head. So cube root numbers, those you have to kind of think about a little bit more. Okay, so 250. To me, I'm thinking that's 10 times 25. 10 would be 2 times 5, and then 25 would be 5 times 5. All right, so 250 broken down. There's all our numbers right there. They're already in order. So that's the third root of 2 times 5 times 5 times 5. And with third roots, when we're doing these, everything we do is in groups of 3. So there's 3 5s. So we can take the 5 out, and the 2 doesn't have 3 of a kind, so it will stay on the inside. So that's 5 times the third root of 2. And then we'll do the same thing with 16. And most of the time when we're doing these, if there's a really good chance that when we do this one, it's also going to be third root of 2, that whatever this number is, a lot of times this one's going to have the same radicand when it goes with it. Doesn't have to, but most of the time we're going to do that. So with 16, that would be 4 times 4. That would be 2 times 2. There's another 2 times 2. So if we break this one down, it's the third root of 2 times 2 times 2 times 2. Okay. And again, because we're doing third root, we have to have a group of 3. Well, there's 3 2s, so we can take that 2 out. There's only 1 left over, so if there's only 1 left over, it's going to stay left over on the inside. So that means we're doing 5 times the third root of 2 minus 2 times the third root of 2. So indexes are the same, the radicands are the same. So if that's the case, you can just cover those up for a minute, that we're really just doing 5 minus 2, which is 3, and then we need the third root of 2. Okay. Give you 1 or 2 more, add, subtracting, just to make sure that we're good with it there, and then we'll move on to the next thing we need to move on to. All right, let's do 2 times the square root of 75 minus 3 times the square root of 50 plus square root of 27. Okay, none of the radicands are the same. They're all different, so we got to start breaking them down. With 75, first thing I'm thinking is it's 25 times 3. And if you break it down with 25 times 3, hopefully that jumps out at you that square root of 25, well, that's a perfect number. When we do the square root of 25 and make that 5, the square root of 3 would be left on the inside. All right, and with the 2 that was in front, that 2 was already 2 times this thing, so it still stays there. So it's still 2 times 5 times the square root of 3. So we can make that one 10 square root of 3. All right, with 50, start to break it down. You can either do 5 times 10 and go that one. I'm going to go 25 times 2. Because if I'm doing 25 times 2, that's already kind of jumping out at me that, again, there's another square root of 25, so I can make that one 5. And that leaves us with another square root of 2. So that's negative 3 times 5. That's a negative 15 square root of 2. All right, and again, if you look at these, 2 different radicands, so we can't add these together. So this one's probably either going to be a square root of 2 or square root of 3 when we start to break it down. If you break down 27, it's 9 times 3. And again, if I'm doing 9 times 3, square root of 9 is a perfect number. That's a 3 square root of 3. And there wasn't anything in front of that one, so for that one, it's just 3 square root of 3. So nothing to multiply, nothing to add or subtract. For that case, that's just 3 square root of 3. Okay, so we've got 3 terms. 2 of them have the same radicands. Both of them have square root of 3s. So we can add these 2 together. So we'll do 10 plus 3 to make that one 13 square root of 3. And then the 15 square root of 2, that's just going to follow back behind it there. So it's going to be minus 15 square root of 2. All right. Now, which one you put first doesn't matter. If you put the negative 15 square root of 2 first and the positive 13 square root of 3 second, that's fine. So which one you put first and which one you put second, there's really no right or wrong answer on that one. As long as the 13 square root of 3 is positive and the 15 square root of 2 is negative, that's all that you have to have when it comes off that one. Okay, so addition, subtraction. There's really not that much to it. If the radicands are the same, you get to add or subtract the numbers in front, but you can just cover that part up and add or subtract whatever's there and just put the radicand there. If they're different, you've got to break them down until 1 or 2 of them is the same, and then you can start adding and subtracting together. It may be that all 3 of them are the same. There should be, if you've got 3 that you're working on, there should always be at least 2 that you can add or subtract back together. It may not necessarily be all 3, but usually there's at least 2 that you can go back and put together. Okay, and other than that, there's really nothing else they can throw at you that's going to be weird or goofy or anything. It's all pretty straightforward for adding and subtracting. Okay, and then we're going to jump back to doing some multiplying that we did yesterday. So we're going to multiply radical binomials. So we're still multiplying like we did yesterday, but the difference is instead of it just being 1 term times 1 term, this one is multiplying binomials together, which means you're going to have to do the full method with these. All right, now if you happen to have forgotten yesterday what we did, first thing we did was if we're multiplying radicals, doesn't matter if it's binomials, as long as you're multiplying radicals, there's 2 things you really have to do that you're going to multiply your outside numbers. Again, we're talking about the numbers outside the radicals. That's what we said yesterday. That's our coefficients. If you have them. Sometimes you have them, sometimes you don't. But if you have coefficients, you multiply those together. The one thing that you'll always have when we're going through these is that you multiply the radicands, which is the inside numbers. And the one thing that you'll do pretty much no matter what we do with any of the radicals that we're going to work with, whether we're adding or subtracting or multiplying or dividing or whatever, is that after you've gone through and done everything you can do, the last thing you always do is you're going to simplify. Okay, so we'll do 3 or 4 of these just so we can kind of see what's going on with it. So we got 3 plus 2 squared root of 5 and then times 2 plus 4 squared root of 5. Okay, so it's 3 times 2 and then 3 times 4 squared root of 5. So 3 times 2 is 6. Nothing you can do there. 3 times 4 squared root of 5 would be 12 squared root of 5. And then we're going to multiply 2 squared root of 5 times both the second numbers here. So 2 times 2 is 4 squared root of 5. And we've got 2 times 4 on the outside for 8. And on the inside, we get 5 times 5, which would be 25. Okay, and then from there, we've done the 1 and 2 steps. So now we're down to step 3. You've got to do some simplifying. Nothing you can do with a 6. It's good to go. But you do have 12 square root of 5 plus 4 square root of 5. You can do, and that's why we have to go by the adding and subtracting first, because when we're doing radicals, you wind up having some addition and subtraction you have to do. So this is 12 plus 4. So that would be 16 square root of 5. Square root of 25 is 8. Sorry, it's 5. And then 8 times 5 means that would be 40. And then one last step, once we've done those parts, you've got 40 plus 6. So just add those two together to get 46. And then the 16 square root of 5, there's nothing you can do to add it, so it'll just stay 16 square root of 5. And just like we said on the last one there's not, if you reverse the order and do 16 square root of 5 plus 46, the answer is okay too. Doesn't matter which one you put first, as long as you've got them both there and the signs are correct, then either one's fine. Okay, so example 2. Let me get one that's got a little bit more stuff to it. Let's do 5 square root of 2 minus 4 square root of 3. And then times 6 square root of 2 plus 7 square root of 3. Okay, so first thing is, again, we'll multiply everything by 5 square root of 2. So 5 times 6 is 30. Square root of 2 times square root of 2 would be square root of 4. 5 times 7 is 35. 2 times 3 on the inside is square root of 6. Now, and even sometimes people will try to get in a hurry, like, oh, I know what square root of 4 is. Okay, before you do anything with the square root of 4, go ahead and write out all 4 terms. So you've got all your full method done. Then you get to go back and do the simplifying, because that you've got plenty of time to go back and get that one. Negative 4 times 6 is negative 24. 3 times 2 is square root of 6. Negative 4 times 7 is negative 28. And then 3 times 3 is 9 on the inside. Okay, and I almost wish they had a check in Math Excel when you're doing this one. They actually had 4 boxes, so you could go back and write down what those 4 steps would be. And that way, if you got this correct, then you know that, okay, if you missed it later on, you know you missed it simplifying. But at least this way, you know you've got all 4 numbers correct. Now you got square root of 4. That part, you can replace that, make that 2. So that's 30 times 2. That would be 60. You've got 35 square root of 6 minus 24 square root of 6. So the square root of 6's are good and they're the same. So we can just do 35 minus 24. Well, that would be 11 square root of 6. And then the last one, you've got square root of 9, which is 3. And if we do 28 times 3, 8 times 3 is 24. Okay, the 2, so that's a negative 84. Okay, so we've got, if we took out the 11 square root of 6 for a minute, we've got 60 minus 84. So if you do 60 minus 84, that's a negative 24. The 11 square root of 6, there's nothing else you can add or subtract with it, so it would just stay the same. So then that would be your correct answer there. And again, you could put the 11 square root of 6 first, and the 24 second. So either one of those two answers would be okay. Okay, two more questions to do with the multiplication, then we'll wrap this thing up. All right, so let's do 6 minus the square root of 12 times 6 plus the square root of 12. And to me, this is the question today, this flashback memory. Anybody remember what that is? That if you're going to multiply two things together that are the same, but only the signs are different. Now, remember what we call that one? Not reciprocals. Somebody was guessing reciprocals in first block. I was like, no. I'm like, you're in the right frame of mind there. Anybody remember what we call that? Perfect squares is getting close. It started with a conjugates. There we go. There's the star verse question today. So that was conjugates. That if the plus and minus sign is the only thing different, we said if you have a conjugate, this is something nice because when we do the full method, here's the great thing about it. We're going to do 6 times 6. We're going to do 6 times square root of 12. So 6 times 6 is 36. We'll do 6 times square root of 12. Well, that's just 6 square root of 12. We'll do negative 12 times square root of 6. So that's basically negative 6 square root of 12. And we'll do 12 times 12 here. That'll make that minus 144. The great thing about multiplying the conjugates together was that these two middle terms knock each other out because it's 6 minus 6, which is 0, square root of 12. Well, if it's 0 times square root of 12, well, that's just 0, so it's gone. So we've got 36 plus 0, which is still just 0. And then the square root of 144, well, that's just a 12. So it's 36 minus 12. So that would be just 24. Okay, so when you're working through these, the answer that you have doesn't necessarily have to have a square root in it. It could be that you work out the problem and you get just a number answer. You also could work these problems out and you make an answer that's just 4 square root of 3 or something like that. So you don't necessarily have to have both parts of the answers. You don't have to have a integer and then a radical part. It could be that the radical goes away and you're left with just an integer. It could be that the integer goes away and you're left with just a radical. So, every answer is on the board when you're going through this. It doesn't have to be a certain way every single time you go through these. Okay, and then the last question of the day. Is 5 plus the square root of 7 squared? Okay, and again, the big thing to remember on this one is you have to do the full method. And some people go, oh, I'm just going to do 5 times 5 and make that 25, and I'm going to do square root of 7 times square root of 7. And again, technically it's the square root of 7 squared, so they would kind of knock each other out, and they'll go, oh, that's 25 plus 7, that's 32. Well, that's great, but you just did the first times the first and the last times the last. You just did the FLA method. You got to get the OI in the middle, right? There is no FLA method. There's no Florida method for abbreviation on that one. So when you get this one where it's 5 plus square root of 7 squared, you've got to rewrite it as 5 plus the square root of 7 times 5 plus the square root of 7. So don't forget to do the OI part on this one, because sometimes people get excited and they just do, ooh, I'm doing this times this, and I'm doing that times that. It's like, well, you are, but you still got to go back and get the O and the I in the middle of it there. Okay, so it's 5 times both of these. 5 times 5 is 25. 5 times the square root of 7 is 5 square root of 7. Square root of 7 times 5, that's another 5 square root of 7. And then 7 times 7 on the inside would be 49. Okay, so we do get the 25. We're good here. This one you have 5 square root of 7 plus 5 square root of 7. That would be 10 square root of 7. There's your O and your I that's in the middle. And then if you square root 49, that would be 7. So we do have 25 plus 7 for 32, but we also have the 10 square root of 7. So it's kind of a halfway answer. That if you do the square root of 7 squared, again, those two things would cancel and give you that one. But you also have to remember that when you do the O and the I in the middle, you're going to get 10 square root of 7. That you have to do that one. So for that one, don't jump the gun and get just the F and the L. Make sure you go ahead and write out both of them. Make sure you do the full method when you go through this thing all the way.